The title of section 7-5 is Exponential and Logarithmic Equations. There are two objectives, one to solve exponential and logarithmic equations, and the other is to actually solve problems involving these types of equations. Okay, so here are the two objectives or targets. Okay. Our example number one, solve exponential equations. So we're going to look at two different types of equations here. Put a line down the center, maybe. Maybe not. That's interesting. Okay, so we'll put a line down the center as best we can. All right, so in our first equation, we're going to look at the two bases and ask ourselves, can I rewrite one or both of these bases so they are the same? Well, I know that 8, so a little side thing over here, 8 is equal to 2 to the third power. So I can take this 8 and do a substitution. So I'm going to replace 8 with 2 to the third. So 2 to the third x is equal to 2 to the x plus 6. Well, raising 2 to the third to the x power is I multiply these two together. So this becomes 2 to the 3x is equal to 2 to the x plus 6. Now, if my bases are the same and it's an equation, that means that my exponents have to be equivalent as well. So I can actually write the equation now, 3x equals x plus 6. And I can solve for x. So if I subtract x from both sides of the equation, here I have 2x equals 6. Therefore, x has to be 3. In my second equation, here I have only a log on one side, an exponent on one side. I can see that I can't think of 5 raised to a power equals 200. So at this point, if the variable is in the exponent position and I can't see a way to make the bases equivalent, my next step would be to take the log from both sides. As a matter of fact, let's just write that down. I think that would be a good thing to do. Okay. So if I can't change the bases, so they are the same, then I should take the log of both sides of the equation. Okay? All right, so that's exactly what I'm going to do. I'm going to go log 5 x to the minus 2 equals log 200. So using one of the rules we've just learned, if I have my variable in the exponent position in a log, I can actually put that out front, x minus 2 times log 5 equals log 200. Then, using my basic equation solving skills, to isolate the x minus 2, I'm going to divide both sides of the equation by log 5. Okay, these will cancel, and I'm left with x minus 2 equals log 200 divided by log 5. And then all I have to do to solve this is add 2 to both sides of the equation, and I get x is equal to log 200 divided by log 5 plus 2. So at this point, I would take my handy dandy calculator. Let's get that going. Okay. So, and I would go turn it on. Let's clear it out. And I would go log 200 divided by log 5. And I get 3.29 to 0.029674. And I'm going to add 2 to that number. So I get x is approximately equal to 5.29. 5.29. So x is approximately equal to 5.29. Done.